All right, so in this video, we're going to set up a proportion from a story problem, and then we're going to solve it just like we did in previous videos. So this problem reads, Susie drove from Verndale to Aldrich, which are roughly 6 miles apart, in 5 minutes. If she continues to drive at the same rate, how long will it take her to get to Staples, which would be 8 more miles after that, roughly? Or maybe it's closer to 7, but I'm just going to say it's 8. Okay, so when we read a problem like this, where we see like two relationships, like a rate as staying consistent, usually that's a telltale sign that we can use a proportion, to solve the problem. And remember, a proportion is when two ratios, and remember, a rate is something that can be represented as a ratio, are set equal to each other. So I'm going to write with this fancy feather pen right here. Okay, so I'm just going to set it up. I could either set it up one of two ways. I could say I'm driving 6 miles. I'm just going to go MI to stand for miles per 5 minutes. Okay, and I think I'm going to solve it the other way after this to show you that there's more than one way to do it. And I'm going to set that equal to, well, the other piece of information that they give me is that even though I'm going to be driving the same rate, so the ratio should stay the same. That's why I can set it equal. All right. It takes 8 more miles. So we have to think, should I put 8 miles in the numerator or in the denominator? It has to stay consistent. So 6 miles is in the numerator on the left side. So that means I have to put 8 miles in the numerator on the right side per, we don't know how many minutes. So normally this is where your algebra textbook would put the letter X, but I feel like that's kind of boring. So I'm going to put a star instead, all right, to represent the minutes. We don't know how many minutes. We have to represent it with a variable, which is usually represented with a letter, but I'm going to use a star. Okay, so now it's just solving it like we have in the past. We have to set our cross products equal to each other. So I'm just going to take 6 times star, okay, which is just 6 star, equal to 5 times 8, which is 40. And then to solve for a star, I have to divide by how many I have, which is 6, divide by 6, and then my 6's go away, and you're left with star equal to 40 divided by 6 is 6 and 4/6, which I can reduce to 6 and 4/6 reduced to 2/3. So it'd be 6 and 2/3 minutes, which would be my answer. Or I could convert it to minutes and seconds, all right, which would be 6 minutes still. And then we have to think, how much is 2/3 of a minute? Well, if we think there are 60 seconds in a minute, so 1/3 of a minute would be however many seconds goes into 63 times, which would be 20 seconds. So 2/3 of a minute would be 40 seconds. So 40 seconds. And this seems about right. I mean, we have, when they're 6 miles apart, it took 5 minutes. If they're 8 miles apart, it should take well, it shouldn't be double, right? It shouldn't be 10 minutes. It's only 2 more miles farther than the previous one, so it should be just a little bit more than 5 minutes. So 6 minutes and 40 seconds seems about right.